Hello everyone, and welcome to the first webinar of the Practical SDV series. This is the beginning of an exciting journey. We are launching a series of webinars where every week we'll explore key aspects of software-defined vehicles and how to make automotive software development more efficient. And today we are kicking off with the very first episode. I'm Ksenia Sternina and I'm Chief Business Officer at SODA, and I'm happy to have you all here. At SODA, we are committed to building tools that make automotive software development faster, more efficient, more accessible. And today we have a perfect person to walk you through this, Alexey Yakovlev, product lead of SODA.Create. Now let's dive in. Alexey, the floor is yours.
Yeah, thank you, Ksenia, and hello, everyone. Happy to meet you here. So the tool Ksenia was talking about is actually called SODA-V. Let me share my screen. I hope you can see it. And our webinars will be built around different topics related to SODA-V, and will include at least 9 weekly episodes. So what is SODA-V? SODA-V is a solution for design and validation of vehicle functionality, electronic systems, and software. And this episode is dedicated to one of its parts, one of the products within SODA-V, which is called SODA.Create. And as you can see, it's related to the left part of engineering V-cycle and is built to support this design stage of engineering V-cycle. Today's episode will be a general overview of SODA.Create's capabilities, main ideas it is built around, and how it actually helps to accelerate automotive software design. In essence, SODA.Create is a collaborative web-based engineering tool which brings together multiple levels of requirements, traceability, architecture, and is very close to the software definition. So it has entities such as software parameters, ports, interfaces, and basically APIs to connect different functional objects within the vehicle. And it also focuses on such things like robust source control, for example, and the kind of deliverables management approach, which enables agile workflows for like collaborative engineering teams. And one of the main goals of SODA.Create, one of the main ideas it was built around, is to streamline the feature-driven approach to vehicle functionality design, and basically to make it accessible, convenient, and easy to follow, even for the engineering teams which might not have a kind of huge, which might not work in huge like automotive enterprises, or which might not have an experience working in such automotive enterprises, but still want to build kind of amazing vehicles, amazing products. And our goal is to help them basically to do it. And to build this overview around, let's consider an example of what we call a vehicle feature specification. It's a special type of so-called design objects, and it's a main tool to build flexible, easily managed incremental process to define the functional scope of the whole vehicle. And to put it simply, the that when you have a high-level definition of your project, high-level definition of your vehicle, maybe it's attributes, kind of business-level requirements, some regulations, because you know what are the markets your product will be deployed on. Then to enable this process, you split your whole vehicle into end-to-end slices of functionality with clearly defined boundaries and potentially dependencies. And then you go deeper into each of them separately to define the specific vehicle level requirements which are related to the slice of functionality, the systems and services which are needed to enable this solution, and how exactly they are integrated, what are the low-level requirements, what are the APIs, data flows, and so on. And those end-to-end slices of functionality, which the design process is built around, are features, so vehicle features. That's the central part of what SODA.Create supports. And yeah, as you see on your screen, to support this idea in SODA.Create, you have an ability to manage the library of such specifications. So you can create new ones, or let's consider this example here of the headlights.
Hi all, we are getting back soon. Give us a moment, please. One of our devices disconnected. Just give us a moment. We are connecting the sound at the moment. Just
Can
give
you
us a second. Yes.
Can you see and hear me again?
Yep.
Yeah, for some reason the camera has just disconnected. But okay, I hope I'm back now and you can see and hear me well. Sorry for this technical issue. Can you still see my screen, by the way? Or not? I guess not, right?
Not yet. Let's
Yeah,
reshare it
so
again.
let me reshare it, no problem. All right, should be back now, right? Good. Okay. So yeah, we were talking about the specifications of vehicle features, which are the central, I guess, object, the central tool which the process suggested by SODA.Create is built around. And in the requirements section, the goal of the section is to define the set of requirements, the set of vehicle requirements specific to this feature, which basically describes the deliverable for this solution. So if your vehicle is considered supporting, for example, headlights version 100, it should implement this whole set of requirements here on the right, and of course should be validated against those requirements. And here we can firstly link the kind of business inputs and design inputs, such as like regulations or stakeholder use cases. There are different types of those. Maybe it's an output of like functional safety analysis. And the main part, as I mentioned, is to define this overall set of vehicle requirements specific to the given feature. So yeah, we can create new requirements or reuse the existing ones from the library, and also we can trace them up to those relevant inputs which we have defined here. So this section basically provides the ability to define this overall vehicle level functional deliverable, trace it up to the kind of business needs, business requirements, and that's what it's about. And the next kind of phase of design process, which this specification supports, is an architecture. So because this is a kind of vehicle level function as one level design object, the architecture describes the detailed design for this. So basically, what are S2 level objects and how they should be put together to deliver the solution. And so having these requirements defined, now you can go deeper and specify what are the kind of electronic systems of the vehicle or like functional services of the vehicle and their instances which are needed to deliver this solution. So considering the example of headlights, we have here like exterior lighting control software. We have its integration with the different instances of lamps. Obviously, it delivers some telltales and receives some requests from HMI, from infotainment system. It obviously is integrated with like user input from light stalk, and has in this example also integration with light sensor to implement, let's say, auto deep beam functionality. So that's what you can do in this section. You can pick systems from your catalog, define their instances, place them on the design diagram, and then for each of them, specify what are the requirements they must deliver in order to support this solution, this headlights 100. So you define those requirements, you define the APIs, incoming, outgoing, ports and interfaces, connect them on the diagram, you can also explicitly state how those requirements should use the available APIs, for example. And having this set, you also can create the next level of traceability link. So now between these system level requirements and feature level requirements. And that's the kind of the good example of what is the scope and capability of SODA.Create. So you can create design specifications on different levels. You can put different objects together, define the integrations and data flows and APIs for to support the higher level design. So, for example, when you have defined your set of features, you can then put them inside the vehicle and specify, therefore, what the whole vehicle should be doing and what is the overall set of systems and requirements, and then the next level as well needed for the given version of the vehicle, for the given release of the vehicle. And what I want to highlight here is that in this specific example, in this vehicle feature specification, you could probably see that it has exactly what is needed for this task, for this stage of the design, no more, no less. So it helps to guide the engineer through the tasks before them. So it helps to make it easier. It guides you through the process. It can highlight all kinds of inconsistencies and potential issues. So, for example, if I would remove the certain connection, then those ports will be highlighted. And when you try to kind of freeze to baseline your design, this notification is provided that you have a potential issue. So it gets you through the process. It helps you to understand the potential issues and inconsistencies in the design. It provides the, well, from my opinion, a nice, clear, intuitive UI to make this task more enjoyable and, again, easier. You can do it faster. And I think that's the kind of the good way to provide the solution which enables you to do the necessary task in a very practical way. So it doesn't have a lot of unnecessary complications. So on this stage, you need to define exactly the requirements for your solution. What is the next level of decomposition, requirements, and traceability. That's it. That's enough on the stage. Of course, then you need to place it in the vehicle, resolve the dependencies, but those can be built as a Lego. So you define those specifications, then you use it as a building blocks in different projects, placed in the different vehicles, and basically when you completed this task in designing the solution once, in most cases, you don't need to repeat it again. You just need to configure it maybe a little bit for different projects, and this would be enough. And yeah, as I mentioned, I hope this example provides a good general sense of the product and its capabilities. As I mentioned before, this episode is just an overview. And in the next episodes, we will dive deeper in various topics like how to transition from the stage where you defined the specifications for separate vehicle features to kind of merge them and create an overall specifications for the vehicle systems which implement all of the features necessary. How then combine those into overall integral vehicle functional architecture. Again, resolve all the conflicts, have all the potential issues highlighted, and have a clear way to manage those dependencies and potential issues. We will also have an episode dedicated to the source control. So how exactly source control works for requirements and different design objects in SODA.Create, how it's implemented, and most importantly, how to use it efficiently, how to utilize it efficiently to manage your deliverables so that you can rapidly iterate and make changes as a team without the kind of worries of breaking anything or lose some data, have issues in design, and so on. So yeah, I guess for this first overview introduction episode to SODA.Create, that's all. If there are any questions, let's, I guess, have some Q&A. Maybe you can provide some ideas what would be the most interesting topics to deep dive into in the next episodes as well. Maybe, Ksenia, if you can highlight some questions provided.
Yeah, we have one. Alfred, thank you for the question. The question is, can I define validation tasks on this level as well on the right side of the V?
Yeah, of course you can do it. That's of course functionality related to SODA validate, but I can demonstrate the example of this. So let's say you have your requirements here on the feature level. Let's just pick one of them. I don't know, this one, for example. So what we can do here, we can create right away a test which is linked to these requirements, where we can define the detailed, basically, validation procedure. Or we can actually ask our AI assistant available in the tool to generate it for us. Let me actually do it. So yeah, I actually forgot completely to mention that besides the kind of good streamlined way to design and perform engineering tasks, responsive interface, collaborating capabilities, like different highlights and suggestions, we also implemented and will implement it more the various intelligent assistance capabilities in the tool. For example, based on AI, of course, as well. So here we have a test generated by our copilot against the given version of the requirement. And as you can see, this test has a kind of set of steps which define kind of functionally how the requirement should be validated. And then we can create implementation scripts to launch automatic test execution on our validation platform. But we will dive deep into it and discuss in details in our next episode, which is kind of dedicated to actually overview and introduction to SODA Validate.
All right.
So I hope this answers your question.
All right, and we have another one from Konstantin. What about the fidelity level of vehicle dynamic in your tool? Can third-party models be used in SODA as well?
I mean, yeah, that's also a good question. So as I mentioned here, in SODA Validate, we have three products. In SODA V, we have three products, which are Create, Validate, and Sim. And so Validate and Sim both have a capability so you can basically import simulation models inside of them and then use them as a kind of automated simulated environment for your tests and kind of whole vehicle simulations. So if we consider the SODA Sim, for example, you can either import here your own dynamics model, but we actually have our own model as well, which comes within the tool. And again, we will cover it in our next episode, the third one, I guess, related to SODA-Sim. But the answer is yes. So in SODA-V, we have a capability to define the requirements and then define the kind of validation simulation program, which can utilize all kinds of models, including model of the vehicle dynamics. And we have our own model provided, but you can, of course, use it as a platform to integrate your own model.
Wonderful. There is another question from Bogdan. Is this a local LLM that you've been integrated, or are you using an OpenAI?
Well, right now, so basically, let's consider the example of Copilot, right? So we have our own backend service, which implements the retriever functionality to kind of index the data and provide it as a context for language models. And right now, we're able to use OpenAI models, and we also support the Anthropic as well. In our roadmap, we have a plan to have our own kind of generative models deployed in our cloud to resolve maybe some security concerns and make it kind of more reliable and robust and cost-effective solution. Right now, we use third-party integrations, but yeah, we have plans to have our own language models as well.
All right, it seemed that we're good for the questions for now. Yeah, I think we were getting to a closure of the webinar if there are no questions anymore. Yeah, I think we're good.
Yep. So again, guys, it will be a regular series of, as you see, short, focused episodes, and we will kind of have it in the following sequence. So there will be an episode for create, then for validate, then for sim, then again for create, for validate, and for sim, etc. So today was the first introductory episode about SODA.Create, and the next one will be about validate. So yeah, if you're interested, we would be happy if you visit us.
Thank you, everyone. Thank you, Alexei. If you guys have any questions or ideas that we should cover next time, please address them into the comments. We will take care of it, and next time we'll cover more topics for you. Thank you so much. Have a lovely day, evening.
Bye-bye.
Bye-bye.